Hi there. Okay, so today we are here. We're going to talk about factoring polynomials completely. Now, we have learned three different methods of factoring out a GCF, greatest common factor, factoring quadratic trinomials, and then factoring difference of two squares. And so today we're going to kind of put them all together. And by the end of this, you need to be able to factor using various methods as needed, but also be able to identify which method is the correct method to use. All right, so let's start with this. Sometimes you might have like a quadratic trinomial that looks like this one here that you see on the screen, 2x squared minus 10x plus 20. And that doesn't look like the typical quadratic trinomials that we factored before because that first term is not a 1. And our rule that we learned, we need two numbers that multiply to the last term and add to the middle term. That rule only applies if that first term is a 1. But in addition, you might notice that each term in this polynomial, all three of those terms have a GCF of 2. So I can actually factor out a greatest common factor of 2. Even though that is a quadratic trinomial, it also has a GCF. So if I factor out that GCF first, so I'm going to factor out that GCF first. I have a quadratic trinomial left over in parentheses, and that quadratic trinomial might be able to be factored again. So here's our rule of thumb. Whenever you see a polynomial and you're told to factor, you always look to see if it has a GCF first. So you always factor out a greatest common factor first. And then from there, you look and see, well, is it a difference of two squares, or might it be a quadratic trinomial that I can factor further? So let's look at some examples. So starting with number 1, we're going to identify the greatest common factor first. So my greatest common factor in number 1 is a 4. So I'm going to factor out that greatest common factor, right? Making sure that I put the 4 out in front of the parentheses. And then I'm dividing each term by 4. And then I'm going to say to myself, okay, well, what's remaining in the parentheses, that's a quadratic trinomial. Can I factor that anymore? Are there two numbers that multiply to 2 and add to -3? So the two numbers that multiply to 2 and add to -3 are going to be -2 and -1. So now this polynomial is completely factored. I used two different methods. I used GCF and then quadratic trinomials, and I can't factor this anymore. Let's try it again with number 2. So number 2, my greatest common factor is actually x squared. So I'm going to divide each term by x squared, and I would get x squared plus 7x plus 10 in the parentheses. And don't forget that we wrote that GCF of the x squared out in front. And when I factor again, so in the parentheses, this is a quadratic trinomial, right? That can be factored more. But I also need to bring down the x squared. So that x squared, that GCF that I factored out first, that stays in front. And the two numbers that multiply to 10 and add to 7, so multiply to 10 and add to 7, are going to be 5 and 2. So that is now factored completely. Okay, what about number 3? So number 3, I notice again is a quadratic trinomial, but does it have a GCF? So it looks like 3 is my greatest common factor. I'm going to divide each term by 3. And so now I have, again, the 3 out in front, a quadratic trinomial in parentheses. Can that quadratic trinomial be factored anymore? Are there two numbers that multiply to 18, positive 18, and add to negative 9? Yep. How about x minus 3 and x minus 6? Okay, so now you've seen kind of what factoring completely is all about. We factor out the greatest common factor, and then whatever's left in parentheses, we look and say, is it a difference of 2 squares? Is it a quadratic trinomial? We didn't see any difference of 2 squares yet, but we will momentarily. These are all quadratic trinomials. So take a minute, pause the video, try numbers 4, 5, and 6, and then when you unpause, we'll put up answers. Okay, so here are those answers for those bottom 3, 4, 5, and 6. And again, you can see we factored out the greatest common factor first. The greatest common factor in number 4 was that 2. And then we look to see what's remaining, the quadratic trinomials, what's remaining, x squared plus 10x plus 21, well, multiplies to 21 and adds to 10. And then that factors into the 2 linear binomials. But please don't forget that the GCF still has to remain out in front. So take a minute, check those 3 answers, and then we'll move on. Okay, let's look at these. So sometimes you might have a greatest common factor, and then you might be able to factor difference of 2 squares. So number 7, you might notice that your greatest common factor is a 6. And so I'm going to factor that out first. And then I'm going to look at what's left in parentheses. That to me looks like a difference of 2 squares. Remember, it's a difference because there's a minus in the middle, and x squared and 100 are both perfect squares. So remember, difference of 2 squares factor into the sum and the difference of 2 terms. So that is factored completely. Again, let's try number 8. I noticed that both of these have the x in them. So my greatest common factor is actually x. I'm going to divide by x. I get x squared minus 25, because these cancel, right? X squared minus 25, again, is a difference of 2 squares. I bring down that GCF, right? And then x squared minus 25, what do I square to get x squared is x, and what do I square to get 25 is 5. And then I need the sum and the difference of those 2 terms. So the third one here, again, I'm looking for a greatest common factor first. I notice that they have a 2 and then an x cubed, because I use, remember, the lowest exponent. So when I divide by 2x cubed, I'm going to get just x minus 49. Now, x minus 49, that is not a difference of two squares, because x is not a perfect squared, right? So I can't factor what's in parentheses anymore. So this one is actually just a greatest common factor. All right, why don't you pause the video here and then try numbers 10, 11, and 12. And then when you unpause, we can check answers. Okay, so you can check these answers, but I want you to keep in mind, you're always looking for greatest common factor first, but sometimes it can't be factored anymore. Like number 10 and number 12, those are not difference of 2 squares, because this is just an x here, not an x squared. So take a minute, check those answers, and then we just have a few more practice problems to go. Feel free to pause the video as needed if you need longer to check. Okay, last but not least, you just have some mixed practice here. So I'd like you to pause the video and try these three, and then when you unpause, you can check them. But again, I want to remind you that you're factoring out a greatest common factor first if you have it. And then you're looking at what's remaining and seeing, can I factor that anymore? Is it a difference of two squares? Is it a quadratic trinomial? Okay, take a minute, check these. And you might notice that I didn't finish off number 15 yet. So I want you to just look at 13 and 14 first. Make sure you're okay with those. Pause the video if you need to. But let's talk about 15. So I took out that greatest common factor, which was 2. And then I noticed that this is a difference of two squares right here. So I'm going to factor this into x squared minus 9 and x squared plus 9. Right? Because I have to square x squared to get x to the 4th. And then I square 9 to get 81. But wait a minute. This is a tricky one. Because look, this is a difference of two squares again. This one here is not, because there's a plus sign in the middle. But this middle term here can actually be factored again. So this is actually going to factor into 2 times x plus 3, x minus 3. This becomes the x plus 3, x minus 3. And then the x squared plus 9 just comes down because that can't be factored anymore. So this is tricky. We actually factored this 3 times. Greatest common factor, difference of two squares, and then difference of two squares again. So that's all there is to it. Just keep in mind, you're always going to look for that greatest common factor first. And then every time you factor out a greatest common factor, you're going to look and see, well, whatever's remaining in parentheses, can that be factored anymore? All right, thanks for watching. Have a great day.